Okay, so I'm just going to introduce you again. So thank you very much for being with us in the LIBREhub seminar series. Lenny, CEO of Protocols.io, to share with us about this very important resource for collaborating and sharing on protocols in the context of open science for protocols in life sciences to make workflows in the laboratory more reproducible.
Thank you, Tobias. It is wonderful to be here. So as I said, I'm co-founder of Protocols.io, and interestingly, because this is part of the bioimaging grant and the community that I'm presenting to, it's just fun to note that the reason I co-founded Protocols.io, the motivation for it was my experimental work in microscopy when I was a postdoctoral researcher at MIT, and it was a single-cell imaging protocol that just was not working for me, and I spent a year and a half trying to figure out what I was doing wrong, what needs to change there. And so most people don't know this, but it's one of the public protocols on Protocols.io. If you find where did I open it? There. If you find this protocol from me, there is a in the guidelines, long story behind it. And this is actually the protocol and my experience where really I changed. It took me a year and a half to figure out that just one step of this protocol, as it was published in Nature Methods, was incorrect and needed a different amount of an enzyme, different amount of time in that 1 out of 50 steps for incubation. And of course, it is not a new technique. It's correction of something that's previously published. So I was very frustrated that I don't get credit for it. And more importantly, everybody else who's using this protocol doesn't know about the change and is getting completely misleading single-cell imaging results, or has to spend a year or two rediscovering that little correction, that little tweak. So that's the story behind Protocols.io. And one of the things, not only do we try to make it easy to exchange and update these details, but the other thing that is at the heart of Protocols.io is improving reproducibility, increasing collaboration. And for any scientist who has read, if you've read any research papers, you're probably familiar with the fact that method sections often and can I just ask everyone on the call to mute themselves because we're recording this, and let's make sure that there's no feedback. So if you're reading research papers, you will often find things like this. Here's a postdoc at University of California complaining that method sections are incomplete. You're looking for a protocol in a 1997 paper. It sends you to 96 paper. The 96 paper says the protocol is in the 1987 paper. You get to the 87 paper, and University of California doesn't have a subscription to it. So you can't actually find the detailed protocol. And I have a long list of complaints exactly like this from researchers in physics and biology, whatever field, you name it, where the methods are not adequately described. It's a very common and very frustrating experience. So I have a long bookmarked list of people saying exactly this. And in 2015, there was actually an effort to systematically take a look at how reproducible are research papers in biology. So it was an initiative from Center for Open Science and Science Exchange, collaborating on Cancer Biology Reproducibility Project, where they looked at top 50 papers in the cancer molecular biology field and just tried to independently repeat the described experiments and There was a lot of news attention to the results of this project, and here in the Atlantic, wonderful science writer Ed Young was saying that the hardest part of this initiative was figuring out exactly what the original labs actually did. Science papers come with method sections that theoretically provide recipes for doing the same experiments, but often the recipes are incomplete, missing out important steps, details, or ingredients. In some cases, they're not described at all. Researchers just cite an earlier study that used a similar technique, as we saw on the previous slide. And if you go to the Center of Open Science summary page for this project, you'll see that 0 of the 193 experiments in those 53 papers had a full protocol that would allow someone else to repeat the work. So that was really challenging. The whole initiative, instead of repeating 50 papers, they contacted the labs that did the work, and often the labs themselves couldn't find the exact protocol that matches the paper. So it was really challenging. And after several years, they just stopped at 18 out of the 50 papers. And so our mission is to make it easier to share these details inside our teams before we publish, and then to make it easier to publish more rigorous and reproducible papers, and to build collaborative communities where we're exchanging the protocols. So that is the motivation for Protocols.io. And I will do a very quick demo, not as detailed as what you'll see in the link on YouTube. But before I switch to the demo, just a summary of where we are. There are 2 sides to Protocols.io. There is the public knowledge base that's Wikipedia-like, or like the public repositories in GitHub. That is open access. It is free to read. It is free to publish. CC BY, and there is over 24,000 public protocols on the public repository. And our business model is, if you're not sharing with the world, but you're sharing internally, that's the part, kind of like Slack for internal collaboration. That's the part that we charge for. So if you're sharing publicly, there is no limit to the number of protocols, free to read and free to publish. And there is about 1 million scientists every year that come to Protocols.io to read these public methods. And out of that million, almost 200,000 scientists have created accounts, and other ones that are creating and collaborating with each other. So with that, I will do a very quick demo of Protocols.io. I'm showing one of the public protocols, and what you will notice is that these are not just PDFs. The protocols on Protocols.io are dynamic and interactive. You can easily add videos into them. There are a lot of in our editor that I won't have the chance to show on this call because I want to make sure we have time for Q&A. But in the editor, there are a lot of components. There's a lot of functionality to help with reporting structured, detailed protocols that you or your colleagues can build on and repeat. And very important from my perspective is that on every step of the protocol, there is a plus button to ask a question. So you can see add a comment. And if you ask a question, as in this example, on the step, it will go to the authors. It will go to everyone who is using this protocol. And if you ask it publicly, you can ask publicly or privately. But if you ask a public question, you're sort of building an FAQ, frequently asked questions, document right on top of the step of this protocol. So these are the conversations that happen not by email or on social media, and only some people who are lucky to be part of that thread see it, but you're building this knowledge base right on top of the protocol. And as an author, as these conversations happen, if you want to improve something, once you've published the protocol, it's fixed, just like a paper, but with a click of a button, you can create a new version and you can always update. And as in my story, you can share, as in my postdoc experience, you can share those corrections and optimizations. You can make those steps easier to understand. So it's not just the comments that are there, but you can easily create a new version. And there is a compare button that allows you to pull up the version side by side to see which steps are the same and highlight which ones have changes between them. Importantly, just as on GitHub, every protocol that you see is essentially a template. There is a fork button on it. So if you are working with different tissues, organisms, if you have a slightly different approach, I'm using Perl, you're using Python or R, we can have differences in parts of our workflows. And so that's where you can take anything that you've shared or any of the public protocols or protocols shared with you, and you can create a copy of it. It becomes editable and you can make changes to it. For hands-on experiments, there is the run button that allows you to actually, as you're doing the work, step through the procedure as you're doing the experiment. If you are setting up or calibrating a microscope or cleaning, putting things together, you can actually, like a checklist, step through it. And if you change anything as you're doing the work, there is an edit button that allows you to say, you know what, today I did it slightly differently. And instead of 1 minute, I did it for 2 minutes, and you can make that change right as you're performing the experiment. So I do want to keep it very brief and come to the Q&A. Before I do that, I also wanted to say that when you're on Protocols.io, you will notice that there are a lot of communities. So if you search, by default, you're searching the 24,000 protocols, but you will also notice that you can search communities, those who create public workspaces. And you can see here's a community reagent collaboration network that was actually started in South America, I think by some of your colleagues. And you can discover communities that are exchanging protocols with each other, that have discussions, sharing resources, and the protocols are not just in a giant bucket of all 24,000 public protocols, but they are organized together in the collaborative workspace. So take a look at communities. You can start one. If you don't see one that is for the techniques and research questions that you're studying and focusing on, you can start a community or check and join communities that are collaborative and open with the sharing, right? Many people know of Protocols.io as a place for hands-on molecular biology techniques, but you will also notice that a lot of people are sharing anthropology protocols, device fabrication, health and safety. So there's, if it has step-by-step instructions, it's like a cooking recipe, right? We welcome it to Protocols.io, and you will see that I'll share the link to this. It's on one of the slides. There is a document that we've created on Protocols.io, which shows examples of protocols from different fields. And you'll see ecology, psychology, but there are also a lot of examples of people creating devices, calibrating devices, explaining how to do imaging, how to set up the microscopes, a lot of videos, a lot of images, and very precise instructions for how to do things, right? So you can easily drop videos into the protocols and make sure that it's not just text, but is information that people need to build on your work, right? And I will finish up with just a few slides. This is a professor from Australia. When we share open protocols, these are not papers on protocols.io. We're not a journal. We don't peer review. Like GitHub or like bioRxiv for preprints, we're a collaborative platform for you to share your workflows. But one of the nice things is when you share openly, as this professor says, you get recognition and you get collaboration because people find your work, they find your detailed descriptions of the methods, and they reach out, they collaborate with you, and it's a really positive experience. And I will finish with one of my favorite examples where a researcher from Chile is asking on social media, does anybody have a protocol for getting RNA out of cortical neuron cultures? And a scientist from San Francisco says, here's one of 5 on protocols.io that should work for you. And what I love about this example is that this protocol actually comes from a research paper in the journal Gigascience that has nothing to do with cortical neuron cultures. It's a paper on parasites of stickleback fish, right? And the authors, because they didn't just add a PDF or contact us for details to their paper, they put a link to the detailed protocol. They made their paper more reproducible, but also because they use the protocols.io repository, they make it possible for anyone to find their protocol and use it outside of the fish parasites that they're studying, right? So the chances that the researcher from Chile who is looking for a protocol in neuron cultures, the chances that he would be reading this paper are close to 0. But when we use repositories as for our code, as for our DNA sequences or protein structures, when we use repositories, we make the methods more discoverable. There are more and more journals and funders that recommend using protocols.io. And I will finish by saying that we really want this to be a tool from day one. We wanted protocols.io to be a global tool, not just for United States. And we recently added, as I finish up, we recently added on every single public protocol translations. So if you open up any of the protocols that you see, you will be able to switch it into one of these 5 languages, including Spanish. And if your university has a subscription to protocols.io, then you can actually start your protocols in Spanish, and when you publish, translate to any of 36 languages that OpenAI supports. So these are automated translations. They're not perfect, but they're pretty good. And it's a new feature that we added on all of the public protocols to increase their global reach. And with that, I will wrap up and we can transfer to the Q&A.
Excellent. Thank you very much, Lenny. This was a really nice introduction.